Hello, am I audible? Can someone check my audio? Hello. Hello. Am I audible? If I'm audible, please say yes in the live chat so that we can get started. Okay, so welcome to free blockchain webinar series coming from Mad Blockchain Group of Mad Blocks Technologies Private Limited. And today we are going to talk about how to create blockchain decentralized application on Ethereum blockchain. Hope I am audible and my screen is also visible. I'll change my presentation slide, check whether my screen is visible or not. And this is a third webinar in the blockchain webinar series that we have organized so far. In the first webinar, we have discussed about how to create smart contract on Ethereum blockchain. In the second webinar, we have discussed about how to create that smart contract. So using Solidity. So we have discussed about different types of syntaxes related to Solidity. And in the third webinar, we just wanted to show you how to use frameworks around the blockchain so that you can start building your decentralized apps. If you want to join our community of Mad Blockchain Group, you can WhatsApp the message as I am the blockchainer to 78930155625. That is my WhatsApp number. You can push me a message. Immediately I'll be joining you into the community. So every week we wanted to do one free webinar on the blockchain so that it creates knowledge, right? So the knowledge is very important. When you have knowledge on blockchain, then obviously you can create some applications around it. So as blockchain is a cutting edge technology, we just wanted to create a knowledge resources because the resources related to blockchain is very less in YouTube and also in Google. So we just wanted to create a simple do-it-yourself blockchain webinar series. So in every blockchain webinar, we just wanted to have hands-on so that you can start working on it. So without any delay, let me jump into the blockchain webinar. So before I get in, if you are not registered for this webinar, you can register on this URL. So https://bit.ly/free blockchain webinar 3. So that is the registration page. Please register on this URL if you are not registered so that we will be sending you a certificate along with this presentation along with the program codes that what we do in this webinar. So this webinar is totally confined to how to create a blockchain decentralized app by using different tools and frameworks. So let me jump in. So myself, I am Madhu Parvataneni. I am the director and strategist at MadBlocks Technologies Private Limited, and my mobile number is displayed on this slide and also scrolling down to this YouTube live. And my email ID is also there, mad@madblocks.tech. So we are available on Facebook, Instagram, and Twitter with an ID called Talk to MadBlocks. So on YouTube, we will be uploading every webinar video on MadBlocks Technologies YouTube channel. So you can keep subscribing to us in order to receive future webinars also. So finally, when we talk about this particular webinar, I'll be talking about what is Ganache and what is Truffle Framework and how to create your decentralized app by using these two tools. And also I'll be showing you how to deploy the test application on the Ethereum blockchain network. So these are the 4 different agendas that I can cover in a couple of hours to show you how to create the decentralized apps. Okay, let us quickly jump into the first part, which is how it is Ganache. So before we talk about what is Ganache, let me tell you who are we. We are the MAD blockchain group community. So on this community, we will be organizing this webinar series in order to create a knowledge. So as we discussed earlier also. So a series of events are lined up on blockchain group in order to explore different types of blockchain platforms and resources. The current strength of the community is 90. So if you want to join the group, you can say, hello, I'm the blockchainer, to my mobile number on the WhatsApp. Immediately I will be joining you into the WhatsApp group. So when we talk about different types of dates, so we have completed the first 2 webinars. So today we are completing the 3rd webinar, which is building a blockchain Dapp. And the 4th webinar is related to how to create a mini blockchain on Python programming language, which is coming up on the next Saturday or Monday, whatever. And also we are organizing 12 hours live workshop on blockchain for about 200 rupees for the community members only. So this price is limited to the community members. If you want to join our 15 hours live workshop on blockchain, which is end to end, so you can join in any of these batches. So we are organizing 2 different batches, batch 1, 18th through 20th October 2020, and batch 2, 29th through 31st October 2020. So on these 2 dates, we are organizing this 15 hours live workshop on blockchain. So we explore different types of tools related to the workshop. So I'll share this schedule in the WhatsApp group so that if you are interested, you can join us. So quickly, let us talk about what is Ganache without any delay. So Ganache is nothing but a personal blockchain, which is for Ethereum distributed application development. So generally, if you want to create any decentralized application, you need a blockchain network, isn't it? So on the blockchain network, your decentralized app will be deployed, and so that it starts communicating with a lot of blocks through the smart contracts and all. So this is what we have discussed in the last few webinars, right? So you will be having a Ethereum blockchain network. On the Ethereum blockchain network, once the information is uploaded onto the network, no one can tamper your data. So we will be using the smart contract in order to avoid a third party in between the 2 mutual parties. If there is any third party, so using blockchain network, we will be removing the third party, and we will be creating a simple smart contract which is deployed on the blockchain network. So whenever the constraints are met, immediately the smart contract will be working on the blockchain, so that the task will be completed there itself. So here, in order to deploy your decentralized app, you need a blockchain server or you need a blockchain network. So Ganache is a open source Ethereum blockchain, so which is your personal blockchain, which is your private blockchain, where you can deploy it on any Windows or Linux or Mac operating systems. So using this Ganache, you can even deploy your applications, or you can develop your applications, or you can test your applications on this platform. So today I'll show you how to use this Ganache. So simply, according to me, if you ask me in one line, if you ask me what is Ganache in one line, so for me it is a personal blockchain network, or you can say personal blockchain server, okay, which is running on my laptop. So my laptop will be acting as a node, which is acting as a peer in the blockchain network. So as it is a personal and private, you cannot access it from outside. Okay, only within the system you can access it, or within the local internet, or within the local network you can access this Ganache blockchain. You cannot access from outside. So this is like this is like your local test network where you can implement your blockchain applications. Okay, so and it is also having some user interface. So generally, some people will use user interface, some people will use command line interface. It supports both user interface and also command line interface. I will be using user interface, and also I'll be showing you the command line interface also. So that so if you are interested in user interface, you can use it as user interface. If you are interested in command line interface, I will also show that, so that you can start working on your applications here. So here, according to me, what is this? So Ganache is nothing but a personal blockchain where you can implement your decentralized applications on this. Okay, where you can deploy it. So let me download this from the website. So the official website of Ganache is trufflesuite.com/Ganache. So if you enter this URL on the browser, so you can easily download. So it supports both Windows, Linux, and also Mac operating system. So today I am demonstrating on Ubuntu operating system. So I just recently shifted my operating system from Windows to Ubuntu for creating different blockchain applications. So I just wanted to demonstrate it. So you can use this URL and you can download the Ganache platform here. So let me do that. So let me enter the trufflesuit.com. Okay, just a minute. Okay, so I have opened it, the trufflesuit.com/Ganache. Immediately you will be seeing this page. So here it will support all, as I said, it supports Windows, Linux, and Mac operating system. As I'm operating on Ubuntu operating system, it is showing as so let me zoom it for you. So here you will have an option called download. So you can simply click on this button. Immediately the setup file will be downloaded onto your system. Okay, so this is simple. This is like one click. So when you click on this button, immediately blockchain application will be downloaded, the Ganache will be downloaded, and using some user interface you can start working on it. Okay, let me show you how to host your personal blockchain network using Ganache here, which is like one click blockchain. So let me download this, but I have already downloaded it. So let me open that. Yes, here it is. So like in order to demonstrate this, I have downloaded recently. This is the setup file which is downloaded from the website there. Let me double click on this. So when I double click on this, as I said, it is like one click. So when you double click on it, immediately the blockchain server will be on. Okay, so it is asking some options here. One is quick start or new workspace. So let me click on quick start in order to quick start your blockchain server. So let me click on it. So when I click on it, immediately you can able to see in a couple of minutes your blockchain server will be on. So this is the personal blockchain server where you can able to see some test addresses also, and test ethers are also available here. You can able to see that. Okay. So this is the blockchain Ganache blockchain user interface. So here you can able to see different types of addresses. Almost 10 addresses will be there, and each address is holding some 100 ethers. So we have discussed about this, right? So in the previous webinar also we have discussed how to get test ethers and all. So by using this Ganache user interface, there are some 100 test ethers for each address, and we can start using this test ethers in order to deploy your application on Ganache platform instead of main Ethereum network. So when you look at the server details, you can able to see here the server is running on an IP address called 127.0.0.1:7545. So this is the server IP address and the port number here, which is 7545. So 7545 is the default port number on which your server is running. So this blockchain server is running on this IP address colon 7545, and it is holding different types of addresses. So and each address is holding some wallet, is connected with one wallet. Obviously every wallet will have an address, so that address is specified here, and test ethers are specified here, and this test ethers and this address will be work only in your machine, because your server is running on IP address called 127.0.0.1, which is nothing but internal IP, which is nothing but local IP here, and then port number called 7545. So let us copy this server details. Okay, so this server details are very important. Let us copy that. Okay, so let me open a simple notepad. Let me paste the server details there. Okay, so which is 127.0.0.1 colon 7545. Okay, so let me increase the font size so that you can able to see it. Okay, so you can able to see. So that is the IP address 127.0.0.1 colon 7545. Okay, so IP address is there. So when you look at this IP address, you can access Ganache server, which is like, blockchain server only within the network, and the port address is 7545. So let me connect this with the crypto wallet. So on the first webinar, I have shown you how to connect Metamask, how to create a crypto wallet by using Metamask extension with Google Chrome or Mozilla Firefox, and we have got some test ethers by using Metamask. By using some test networks, we have purchased some test ethers also, right? So in the similar way, let me connect my Metamask wallet with this Ganache server, so with this blockchain server. So let me open my Metamask. Let me open my Metamask. So let me minimize this. So on the browser, you can able to see the extension here, which is Metamask. Okay. Okay, it is asking password. Let me enter my password. Okay. So you can able to see the Metamask crypto wallet. Now I will connect this crypto wallet with the Ganache. So here what I'll do is, on the server, you can able to see different types of addresses, which is the wallet address, and every wallet is connected with some balance which is of 100 ethers. So let me use this ethers. Okay, let me use the first address. Okay, let me click on the private key. So every wallet will have a private key. Okay, so you can able to see some key icon, and when you click on that key icon, you can able to see, you can able to get its respect to private key there. So let me click on that. So when I click on that, you can able to see what is the wallet address and what is the private key. So this private key will work only within the network, because it is a server which is running on 127.0.0.1. So let me copy this, copy, and let me click on done. Let me go back to Metamask. So in the Metamask, on the Metamask, what you have to do is, you have to click on the account icon. So you have to click on import account. So when you click on import account, then it will be showing you where, how to use, where to paste your private key. So select type. I'm importing the wallet. So my wallet is there on the Ganache. So I'm importing that wallet by pasting the private key. So I have copied a private key of one particular address, and I will paste the private key here. When I click on import immediately, so this account will be connected. Okay, so let me select my server also. So let me remove this as of now. Okay, let me show you how to use that. So here I have given the account, the wallet address here. Let me connect with Ganache. Okay, so then what I have to do is, I have to click on custom RPC. So my network, I have to connect with the local host. Okay, so the default one is 8545, but here my Ganache is running on 7545. So let me click on custom RPC. In the custom RPC, let me write at network name my Ganache so that I can able to understand. So it is running on an IP address called http colon 127.0.0.1 colon 7545. So that is a port number, and 127.0.0.1 is the IP address of my server, and port number is 7545. So let me scroll down, let me click on save. Okay, so it is now connected. You can able to see 100 ethers. You can able to see 100 ethers, and also you can able to see the account address. So the same account address, say it is ended with 3147. You can able to see that 3147 is the last 4 digits. So when you go back to Ganache, you can able to see 3147. So 3147 is nothing but the first address, as I copied the its respective private key on the Metamask, so I can able to get this wallet address there, and I can able to see the balance 100 ethers. So on the Metamask wallet also I can able to see the 100 ethers there. Okay, they both are connected. So now Metamask wallet is connected with Ganache for making some transactions. Okay. For making some transaction, it is account 43147. It is having 100 ethers as of now. So by using this test ethers, we can make some transactions on the network, so that we can easily deploy the application. Okay, so let me jump back to the presentation. So up to here, what I did, I have shown you how to connect your Ganache, which is personal blockchain server, with your Metamask crypto wallet. So make sure that your crypto wallet is connected to the network. When it is connected to the network, when you deploy your blockchain web application or blockchain mobile application, then this wallet, by using this wallet, it will make some transactions. For example, say when you have phone pay on your mobile phone, if you want to transfer some money, so make sure that you have a phone pay, and phone pay should be connected with proper bank account, right? When it is connected with proper bank account, when you make any transaction, so immediately phone pay will be sending a query to the bank server, and the bank server will be querying all the details according to the account number and all. And if you have balance, immediately that money will be will be deducted from the bank account, and it will be transferred to the second person whom you want to transfer on phone pay application. So here also, if you want, what is bank server here? Bank server here, it is nothing but blockchain server. So blockchain is a distributed server, right? I should say duplicated server instead of distributed, because in blockchain you will have duplicated peers. So every peer will have all the information. So every peer will have all the information related to the blockchain, which is like, duplicated. So once you add one block on one peer, the same thing will happen at every peer, right? So it is like a duplicated blockchain servers. Okay, instead of distributed. But the computing method is distributed, but simply to understand, it is like a duplicated. Okay. Anyways, now the Ganache is connected with our Metamask crypto wallet successfully, and let us talk about what is Truffle Framework. Okay. So let us talk about the second topic, which is very important. These are like pre-requirements. In order to deploy your decentralized app, if you want to deploy an app, you need a server, right? So that server is nothing but the Ganache server here. And Truffle Framework. So what is this Truffle Framework? Let us understand. Truffle Framework is nothing but a development environment which is used to create some applications which are deployed on the Ganache blockchain Ethereum network. Okay. So this is like a development IDE. This is like a development environment, I should say, not an IDE. It is like a development environment which makes the developers, process simple, so that it can be deployed. You can deploy easily either on a main network or either on the local personal networks like Ganache and all. Okay. So it is like a framework which is used to deploy smart contracts, or which is used to compile your smart contracts, or it is used to test your smart contracts. So it is mainly used for building decentralized applications on Ethereum blockchain network. So here it can be you can connect this Truffle with blockchain, which is Ganache, which we have deployed in the previous step. Okay, this is like a framework. This is like an environment for developers to build some decentralized apps. Okay, it is also having an interactive console. I will be showing you what is this interactive console in the next step. But as of now, this framework, by using this framework, we can easily develop applications related to dApps on Ethereum blockchain network. And also you can easily create programs, you can easily compile your programs, and easily you can link your programs, and also you can easily deploy your programs onto the network. So it is like, the process of building becomes very simple when you use this particular framework. So it is also having an interactive console. Okay, so let us do that one by one, step by step. So there are 5-step process in order to understand this Truffle framework. What is this, how to compile, how to create. So let us understand that. Okay, let me open command prompt. So as I'm doing it on Ubuntu, it is Linux terminal, right? So let me do it. So let me open command prompt. Okay, so let us understand how to create a project. So by using this Truffle framework, let us understand how to create a project. If you want to create a project, make sure that you have to install this framework. Okay, so the command to install this Truffle framework is that npm install Truffle, but make sure that you have node.js on your machine, and also you have node package manager also, which is installed. So that is a prerequisite. Okay, if you want to deploy your applications, you have to install this framework. If you want to install this framework, make sure that you have the node.js and also npm installed on your system. Okay, let me use this command, which is npm install Truffle. So that is used to install the Truffle framework on your system. So let me do that on the command prompt. So npm install Truffle. Then immediately, as I have the node.js and npm installed together on my system, so you can able to see the files are downloading here. So in a couple of minutes, this Truffle will be installed. So by using this framework, we can easily deploy, and also we can easily develop applications related to the decentralized apps. So in the next part, I will be talking about what is decentralized app and all. Only to understand how to work with Truffle, I just wanted to show you here. Okay, it is already there, so let me put permission also. Okay, it's already there. Let me clear this. The simple command is sudo npm install. It's simple, sudo npm install -g Truffle. You can easily install this. So let me check whether it is installed properly or not. So Truffle space version. So when you type this, it will be showing you what are the versions of the tools which are added to the Truffle there. So you need a compiler in order to compile your smart contract, right? So you need a Solidity compiler in order to deploy your application. You need node server, because we have to run the server, we have to deploy as a server. So you need node. So node version is v 10.19.0, and also you need a framework which is web3.js. So this is a JavaScript API in order to connect your front end and back end. So I will explain that in the next part. But as of now, web3.js is nothing but an API which joins your front part and back part here. And the Solidity, we are having a compiler version of 0.16, and node version is 10.19.0. So in every smart contract we have to import the compiler version, right? So that is why you have to remember this. So 0.5.16 is the compiler version of Solidity. So this has to be imported in every line of the program, right? So we have to remember this. So Truffle is installed. So what do you mean by Truffle as of now? Truffle is nothing but a development environment which comes with predefined tools like compilers, something like Node, something like web3.js. So we have not installed web3.js, right, directly. So if you install Truffle, then what will happen? All the applications related to the blockchain decentralized apps, it will install automatically when you run this command. So by using this Truffle, we can easily deploy applications. But when you install Truffle, then Solidity compiler will be installed. Web3.js, which is a JavaScript API for Ethereum blockchain, that will be installed. And Node, if you want to run a server, if you want to run a web server, you need Node. So we will be using Node here. So that is all, that will also be installed. Okay, so everything is installed. As of now, Solidity compiler is 0.5.16. Okay, so step 1. So let us create a folder. Okay, so let us follow the presentation. So here we have installed the Truffle, and the step says we have to create a project. Okay, I just wanted to show you the process of using Truffle. Okay, how to use this Truffle framework and all. So here step 1 is we have to create a project. If you want to create a project, you need to create a folder. So let us do that. mkdir space meta coin. Okay, let me type same as presentation, meta coin, M capital, C capital. You can write any name. Okay, so mkdir, so this is existed. Okay, let me delete that. Okay, so let me create a folder, mkdir space meta coin. Okay, after creating a directory, we need to enter into the directory by typing cd space meta coin. Okay, so we have created a project folder, and then we have entered into that project folder. So every files which are related to this project will be in that folder. Okay, so as we are using Truffle framework, you will get a lot of files. Okay, I'll be putting all those files in the same directory there. Okay, so step 1 is done. Step 2, we have to unbox some default application. So if you want to understand how Truffle will work, so I'm using this default project called MetaCoin. So here what I'll do is I will unbox it. I will download that project from Truffle server. Okay, so let me do that, which is like Truffle space unbox space MetaCoin. Okay, so this is MetaCoin. This box is a default box which is there in the Truffle server. Okay, in the bootcamp I'll show you how to create your own box, but as of now I'm using a default box that is available in the Truffle framework. Okay, so let me hit enter. So when I hit enter, that box will be downloaded and it will be unboxed. Unbox is nothing but the files will be extracted into the MetaCoin folder. Okay, so the box will be downloaded and you can able to see. So the files are downloaded, and when I type ls, so ls is nothing but listing out all the files in the current directory. So you can able to see a folder like contracts, a folder like migrations, a folder like test, and also truffle-config.js. So these are the different files which are downloaded. So when I run a command called truffle space unbox space MetaCoin, so in Truffle suite, so you will see some Truffle boxes. So Truffle boxes are nothing but a box which is holding some set of files. Generally in PUBG also some one box will be dropped from the sky, right? So that box will be holding some weapons. So here also you will have this kind of boxes, okay, which are called Truffle boxes. So this Truffle boxes will be holding some set of files, so that anyone can be download and they can use them in their project. So as of now, in order to understand how Truffle will work, so I'm just using this box called MetaCoin. I have downloaded it by running a command called truffle space unbox space name of the box. Okay, and here you will be able to see different types of folders like contracts. So in the contracts folder, you should place all your smart contracts, and migrations folder, you have to place all the default, the scriptable deployment files in the migration folder. In test folder, you have to write some test scripts in order to check your smart contract whether it is working or not. In truffle.js, so this is the configuration file. So that configuration file will also be there when you download, when you unbox the MetaCoin folder. Okay. So this is also we did, and I have shown you all this contracts, migration, test, and all. Okay. So let us test. So let us test this project. If you want to test this project, let me jump into the command terminal here. So I'm using Ubuntu operating system. So I'm using Ubuntu terminal, Linux terminal there. So let me jump into test folder. So cd space test, immediately that will enter into test folder. Let me put ls enter. If I put ls enter, you can able to see test metacoin.sol. So test metacoin.sol is nothing but test file in order to check whether your smart contract is working or not. So let me also show you the script of smart contract which is downloaded. So let me jump back, cd space dot. Let me type ls enter. You can able to see contracts folder, cd space contracts. In contracts folder, you will be putting all your smart contracts here. For example, say, so there are different Solidity files. One is for migrations, which is a default file. One is called metacoin.sol, and one is called convertlive.sol. Okay, so metacoin.sol is the important file because that is a smart contract which is holding a smart contract. Let me open that file. Let me show you some functions which are written in the smart contract there. So sudo space, I'll be using nano editor, nano space metacoin.sol. Then you can able to see some code which is already written. Okay, but in the third part we'll be writing our own smart contract, but here I just wanted to show you the MetaCoin. So MetaCoin is nothing but something like which is virtual coin where we can transfer money, okay, from one account to another account. So here we have a contract called MetaCoin, okay, and there is a constructor object here. In the constructor object, what is a balance? So balance it is nothing but 10,000, right? So the balance is nothing but 10,000 here. So we have whenever the smart contract is initiated, so immediately constructor will be called automatically. So in the constructor, what is the balance it is showing? It is showing some 10,000 coins as a balance, which is a default balance here. And also there is one function called send coin. So in the send coin, you will have two parameters here, receiver and amount. So when you pass receiver and amount, obviously it will be sending that number of coins into the receiver, which is with a function called send coin. And get balance in ethers. So get balance in ethers is nothing but the number of ethers will be calculated from the account, which is like balance coins, okay, balance ethers, or you can say. So get balance. So there are two different functions here. One is get balance in ETH and also get balance. So these two functions will be returning balance, but when get balance in ethers is returning balance in ethers, and get balance is returning number of coins that are available in the account. Okay, there are three functions here. One is called send coin. So when you use the send coin, then immediately the number of coins will be sent to the receiver. That is why he is using two arguments here. One is receiver, second one is amount. Okay, so get balance and get balance in ether. So all these three functions are there in the contract, okay, in the metacoin.sol. So let me exit from this and let me let me show you what is there in the test folder also. So cd space dot, it will go back, and cd space test, okay. cd space test, let me show you ls. So there is test metacoin.sol. Let me open that file, sudo space nano space test metacoin.sol. Let me open it. So here this is a test file, so which is used to test MetaCoin smart contract. So here there is an expected balance like 10,000. There is an expected balance called 10,000. Okay. So it is just comparing whether the smart contract is holding that balance or not. So here, what is expected here? So in the previous step, I have shown you the balance amount, right? So what is the balance amount? 10,000. So here expected balance. So expected balance is also 10,000. When the smart contract is initiated, the same balance will be stored in the balance variable, right? Until unless you send some coins, so you will have the same balance. So that is why. So it is comparing. So it is calling dot get balance. So dot get balance is nothing. Meta dot get balance is nothing but getting the balance from the smart contract. In the smart contract, we have 10,000, and here also expected value is also 10,000. If both are equal, then immediately nothing will happen. If both are not equal, then immediately you will get an error called owner should have 10,000 meta coin initially. So asset. So asset is nothing but error handling. When you get any error, say if your wallet, if your smart contract is not holding 10,000 coins, okay, say some manipulation has been happened there, say you have only 9,000. So then obviously what will happen? 9,000, 10,000, they are not equal. So you will get a warning saying that owner should have 10,000 meta coin function initially. Okay. So if you transfer some money, okay, if you transfer some money, then obviously the coins will be reduced, right? Then immediately you will get this error. Okay. So the both test functions are written in such a way that it will initially understand whether you have the same coins or not. Okay. So let me jump out of this program. So initially the result is 10,000 coins, right? So we have to test whether the smart contract is holding 10,000 coins or not. Okay, how to do this? So in the presentation, so I'm going according to the presentation only. So here we have to test. If you want to test your Solidity, file, you have to use a command called truffle space test. Okay, so let me run that. Truffle space test space. So this test file is in test folder. So you have to write /test/ the name of the file is test metacoin. So test metacoin.syl. Immediately when you hit enter, it will try to verify whether your smart contract is having 10,000 coins or not. See, compiling. So all the files are compiled, all the smart contract files are compiled. So you can able to see the contract files, the smart contract files, which are like SYL files in contract folder, and SYL file in the test folder is also compiled there. As we are compiling test metacoin.syl, it is calling the previous contracts which are stored in the contracts folder. So you can able to see that. So everything is compiled successfully. There is no error in the smart contract file. So everything syntax is correct. So we have to, it has to pass, right? So you can able to see 2 green marks. So you can able to see 2 green ticks here, which indirectly means that there is no problem. So your smart contract is working good. Okay. So here 2 are passed in 13 seconds. 2 are passed. So you can go for the next step here. Okay. So they are passed. So you can deploy this onto the blockchain network. Okay. So both files are passed. You can go for next step, which is deploying the onto the blockchain network. So before we deploy the application onto the blockchain network, so let me compile the project. If you want to compile the project, you can type truffle space compile. So truffle space compile is nothing but compiling the project. So let me hit enter. So previously also the files are compiled. I don't see any error now. So the project will be compiled, truffle space compile. So all your smart contracts. Now the smart contracts are there in the contracts folder. So that contract folder will be compiled. So when it is compiled, then obviously the application binary interface will be generated by the compiler. That ABI, so application binary interface, is very, very important in order to connect with the smart contracts. That will be stored. So you can able to see an artifact. An artifact is written to home/mat/metacoin/build/contracts. So every file, let me enter into this path. Let me show you that. Let me type cd space build. So in cd space build, the artifacts was written. Artifact is nothing but JSON file here. Let me show you that. So cd space contracts. So we are in MetaCoin build contracts. Let me type ls, enter. If I type ls, enter, you can able to see 3 different JSON files which are nothing but artifacts here. So one is for convert live.json, because we have convert live.syl here. So we have this Solidity file. So the respective JSON file is available in the build contracts folder when you compile the project. So immediately metacoin.syl is having its own metacoin.json file in build contracts. So in this JSON file, you will be having its application binary interface, and also the, whenever you deploy this on the blockchain network, all those details will be added to this JSON file. So as of now, you can able to see the application binary interface. Let me open that file. Let me show you that. Sudo space nano space, nano is name of the editor, space metacoin dot JSON. So it will be holding some JSON file in JSON format, which is nothing but the application binary interface. So it will be holding all different types of inputs, all different types of outputs. Everything will be written into this file. Okay, this is called application binary interface, and you can able to see different types of bytecode also. So the compiler will be converting the Solidity file into the bytecode file. Okay, everything you can able to see it here in the artifact. So every artifact will be generated for every Solidity file. So here there are 3 Solidity files, thereby you can able to see 3 JSON formats. Okay, so for deploying this, we will be using this JSON file. Okay, so let me jump back to the presentation. So the project is compiled, and the first and the last step is migrating the project. So in order to migrate the project, truffle space develop. So when you enter this, immediately your project will be deployed. Okay, so let me go back and let me type this. Okay, truffle space develop. So when I say truffle space develop, immediately your smart contracts will be compiled for once again, but they are like, they don't have any error, right? So it is up to date. You can able to see the accounts. Okay, so this is a CLI. So I have said earlier, Ganache is available in CLI. So test RPC, this is particular test RPC. This is called the CLI interface, where you can able to see different types of accounts, and each account will be holding some 100 ethers. So you can able to see 0 to 9, 10 different addresses, which means 10 different wallets. Each wallet will be holding some private key. Okay, will be holding some private key, and by using this private key, you can able to deploy your contract. Okay, so as of now the contract is not deployed, but let me show you how to deploy it by using Truffle console. Okay, so here we have 10 different addresses, and 10 different private keys, which each address is holding some 100 ethers. Okay, which are like test ethers. So let me show you that. Okay, so let me jump back. So here what we have to do is we have to type migrate. So when you type migrate, immediately the top address, so address of 0 will be taken into consideration. So let me type migrate on the console. Let me type migrate. So immediately the blockchain contract which is written, smart contract will be migrated onto this blockchain server. So here your blockchain server is holding on 127.0.0.1 colon 9545 here. Okay, so this is one instance where this is called test RPC CLI. So this is also a personal or private Ethereum blockchain server, and it is running on 9545 here. You can able to say it. So port number will be varied from 1 to 1. So I am getting 9545. So when I type migrate, immediately your contracts will be compiled. So everything is up to date. There is nothing to compile because previously we have compiled it, and we have deployed the the smart contract here. You can able to see the contract address. So one address will be generated for every smart contract. By using this address, we will be communicating with that contract, which is contract address, and the block number is 1 because Genesis block is created. Okay, this is block 1, and you can able to see the account here 0B2 B35 2130. So that is the account. Okay, so 2130, you can able to see 2130 here. So as I said, address of 0 will be taken into consideration if nothing is mentioned. Okay, you can also pass parameters. You can also pass parameters like accounts of 0 or accounts of 1 or accounts of 2 and so on. But here, if nothing is mentioned, so that will be considering the 0th account, which is like 2130. So that is why you can able to see the address of the wallet is 2130. Okay, so account address of the wallet is 2130, and you can able to see the balance. So the previous balance is 100 ethers, but as of now, what happened? So an account and a transaction is made. So what is a transaction? The transaction is nothing but creating a smart contract, right? So deploying a smart contract. So a smart contract is deployed. That is why the number of ethers has also reduced. Your balance is also reduced from 100 ethers to 99.9967165. And you can able to see what is the cost of this transaction, which is like 0.0032835 ethers has been transacted as a transaction fee from the account. So that is why the balance is 99.996 and all. And also a contract call has been made here, and you can able to see the block number. So, and you can able to see the transaction ID, where is this transaction hash, and also and the contract address. So 05AF, and you can able to see the amount balance here which was deducted and the total cost. So like this, everything will be deployed. Okay, so everything will be deployed. Every contract will be deployed onto the server, and in order to deploy that smart contract, some amount of transaction fee, some amount of gas will be charged, and the amount will be deducted from the wallet. So the total number of deployments are 3, because there are 3 SOL files, right? So there are 3 SOL files, thereby the total number of deployments are 3, and the final cost of this transaction is all about 0.0109242 ethers, and the remaining balance you can able to see there. So here, without using Metamask wallet, we have made our transactions through simple CLI. Okay, through simple Truffle console, we can able to make some transactions, okay, directly, without using any Metamask wallet or without using any Ganache servers and all. Okay, let me jump back to the presentation. Let me show you how to interact. Okay, how to interact with smart contract. So let us run some commands here. Okay, so in order to check your smart contract. So let me jump back to the console. So here, let me check some commands. Okay, so let me write, am I audible? Let me write let instance equal to await metacoin. We have to create an instance of the deployed address. Okay, so that is why we have to do that. So let instance equal to await space metacoin.deployed. So we have to begin we have to establish a communication between your smart contract and the CLI by using this instance, and also we have to tell the the console which account you wanted to use. Okay, there are 10 accounts here, right? So that there are 10 different accounts, so we have to use one account of the 10 accounts which are been displaying there. So let accounts equal to let is a keyword here, await. So await is an asynchronous communication here until unless you select one account, so it will not be assigned. Okay. So await space web3 dot ethers dot get accounts. So one account will be selected, and that account you can able to see in accounts variable. Okay. So let me check what is the balance. Let balance equal to await instance. So what is instance? Instance variable dot, we have to call the function here, and the function is get balance. This is a function which is written in the smart contract, and we have to pass accounts here. So we have 10 accounts, so we have to pass one particular account out of 10 by using its index. So if you make 0, so from 0th account the transactions will happen. So let balance equal to await of await space instance dot get balance. So get balance is the function which is written in the smart contract. Enter. So now let us see that balance. If you want to see that balance, we have to convert that into number because that is an object there. So balance dot to number. So balance dot to number is nothing but where you can able to see the number of coins there. So initially, so you will have 10,000 coins, right? Initially you will have 10,000 coins. So let me transfer this coins. Okay. Let me transfer this coins, and also let me show you the function called get balance in ETH also. Okay. So let me type let ETH, or you can say ether equal to await instance dot get balance in ETH of accounts of 0. So initially I am checking what is the now what are the number of coins in the smart contract, and also I am showing what are the ethers that are available in accounts of 0. Okay. Let me convert into number. If you want to convert into number, you have to write variable name to number. Okay. You can able to see. So these are the coins that are available. These are the ethers that are available initially. So 10,000 coins and 20,000 ethers. Okay. Let me send some coins. Okay, from one account to another account. So let me write instance dot send coin. I have to write receiver here, right? Receiver. So say accounts of 1. Okay, from 0th account to first account. Accounts of 1 comma 500 coins. So here what will happen? From accounts 1, from account 0 to accounts 1. So the coins will be transferred. Okay. So let me hit enter. You can able to see, and transaction is made. So you can able to see transaction hash, and also you can able to see receipt here, which is like transaction hash and the transaction index, block hash, block number, and also you can able to see the amount of gas used. Okay. And let me check what is the balance now. Okay, let me check what is the balance. Say now we have transferred 500 coins, right? So initially it is 10,000. Now when you check balance, you should get 9,500, right? So let new balance equal to await instance dot. So what is your account here? Instance dot get balance of accounts of 0, isn't it? Accounts of 0 is nothing but your account, accounts of 0. So let me convert into number. New balance to number. You can able to see the balance there, which is nothing but 9,500, because we have transferred 500 coins from account 0 to account 1. So let us check whether the coins are received or not. So let space received equal to await. Okay, await is an asynchronous communication. So it will wait until the function returns the value. Okay. So get balance in ETH, get balance from accounts of 1, because we have sent these coins to accounts of 1, right? Now you can able to see whether the coins are received or not. Okay, let me convert that into number. Received dot to number. Okay, let me see the coins there. So how many coins are there? 500. So initially it will be 0, because it is the account 1, right? So which is the receiver's account, it is having 500. So let me send a few more coins. Okay, let me send some coins. Okay, let me send finally, in order to conclude this, let me send some more coins. Okay, so here what I have to do in order to send coins, instance dot send coins, send coin of what is the receiver. So receiver is accounts of 1, receiver is accounts of 1. Let me send 1000 coins. Okay, so previous we have sent 500 coins to accounts 1, which is receiver's address. Account of 0 is our address, account of 1 is receiver's address. So let me hit enter. So when I hit enter, the transaction is made, and let me check the balance. Okay, so if you want to check the balance, so let me use a function. Let me say let new balance equal to await instance dot get balance of accounts of 0. So we have transferred 1000 coins, right? Instead of 10,000 we have transferred 1000. So previously we have transferred 500. So total 1500 coins we have transferred. Okay. Okay, let me use one more variable, new balance 1. Okay. So let me check what is the number there, how many number of coins left. So initially it is 10,000 coins. Now you can able to see only 8,500 coins here. 1500 coins have been transferred from one account to another account. Let me check whether it is received or not. Okay, so say let received 1 equal to, it's a variable name, await instance dot get balance of accounts of 1. So in this account you should have 1500 coins, because we have transferred from account 0 to account 1, which are 1500. So let me convert into number, received 1 dot to number. Okay, now you can able to see 1500 coins. So like this you can easily communicate with smart contracts from the Truffle console. You can easily call them by using this let variable and also instance variable. What we have to do here, we have to initiate the instance and then we have to select one account. Okay, so here if you see our instance has been created by calling metacoin.deployed, and then we have selected the accounts of 0 as our address, and we have transferred some coins from account 0 to account 1, and also we have made some transactions here. So you can able to see the number of coins left and the number of coins received. Okay, so this is what I wanted to show you, how to use Truffle console. Okay, so that's all. Let me jump back to the presentation also. So, any questions? If you have any questions, you can ask in the YouTube live chat, or you can also post in the WhatsApp group. Okay, so after the webinar I will address all those queries. If you have any queries as of now, you can post in the YouTube live chat, or you can later, if you are watching this YouTube live later, so you can also post in the WhatsApp group, or you can post to my mobile number which is scrolling down to this YouTube live. I will be able to answer these queries. Okay, so this is how the Truffle development environment is able to handle different types of smart contracts which are used to deploy. So as of now we have not used any web application. As of now we don't use any mobile application, right? So let us quickly understand what is Dapp, what is decentralized applications, and then slowly we'll start working on how to create your first Dapp on Truffle and Ganache. Okay, so these are basics. Okay, if you want to from here the right topic will start. If you want to understand how to create your Dapp, you need to understand how Truffle will work. So in Truffle, if you see, you will have contracts, you will have migrations, and you will have test. So you have to create a smart contract. After creating smart contract, you have to migrate that smart contract onto the blockchain network. So if you want to migrate it, so you will have a command called truffle space migrate. So that will be migrating your contract, and that will be creating the application binary interface ABI, and using that ABI. So once a smart contract is deployed on the network, so you will be getting the smart contract address. By using the smart contract address and ABI, an artifact will be created, and by using those artifacts we will be communicating with the smart contracts on the blockchain network. Okay, so let me jump into the next part, which is how to build your DApp. So before we understand how to create DApp, so let me tell you what is DApp briefly for about a minute, and then slowly we'll jump into the topic. So what are DApps? So decentralized applications. So DApp is nothing but decentralized application. So when you talk about decentralized application, you have to talk about what is centralized application also. So generally, if you look at the scenario, if you look at the image which is placed beside the topic, so on one side you'll have apps. So generally those are the apps which we use in our daily life. And the second one is DApps, which is like, the apps which are communicating with the decentralized blockchain network. Okay, in normal apps, what will happen? Your mobile application, for example, say when you look at Facebook, your Facebook will be communicating with Facebook server. Okay, you can have, n number of people, and every fellow is having Facebook application installed on their mobile phone. That Facebook application will be communicating with central server. So what is a central server? That is called database server or data servers, right? So which is called data center regions and all. So at different data center regions, they will be hosting the server, and to that server, your application will be connected. So all your data will be at a centralized place. So when you have data at centralized place, they can hack your data, they can change your data, they can grab your data and all. Okay, they can update, modify, delete, whatever they can do on this centralized server. But when you jump from apps to decentralized apps. So what is decentralized apps? Decentralized apps will also a mobile application or a web application which is deployed on the blockchain server. Okay, and this DApps will be communicating to the blockchain network. You cannot tamper your data, you cannot modify your data, you cannot delete your data, you cannot do anything there, which is like, your data is encrypted, it is open to everyone. So you will have public blockchains, you will have private blockchains. When you have public blockchains, Ethereum blockchain is a public blockchain. And if you talk about, blockchains, generally it will be of three types: public, private, and, hybrid blockchains. So which is like, consortium blockchain. So here decentralized applications are nothing but, the applications which are connected to a decentralized blockchain server. So generally when you look at app, you will have front end and back end, right? So front end is nothing but the user interface, and backend is nothing but, the server connections or the database the database access and all. So that will be there at the backend. So any application, it can be a mobile application or it can be a web application, you will be having a front end and back end in a normal centralized applications, and also in the decentralized application also you will have front end and back end. So for example, say if Facebook has decided to change their centralized server to decentralized blockchain server. Okay, say if your Facebook is interested to move from a centralized server to a decentralized server, will your Facebook application change? So will your Facebook application change or not? Will your UI affects or not? So the important point which you need to understand is, the user interface will never change, though you have a centralized server or though you have a decentralized server, your user interface will never change. The only it will change is backend. So backend, anyways, you cannot see it from your mobile application, because your mobile applications are like, front-end applications. They will be connecting on the backend, backend servers, right? You cannot able to say it. So it is a programmable place, right? So whatever you see, whatever you feel, that is like front-end. So they will be using HTML, or you can use PHP or you can use JavaScript. So you can use different types of programming languages in order to create user interface, and that user interface will never be affected. Okay, so if you look at one application and you cannot say whether it is implemented on the blockchain or not, because the front end will be looking same, but back end will reverse. Okay, the back end in the mobile application or in the web application, from a centralized application to decentralized apps, they will change. Okay, and decentralized applications will be connected with crypto wallets, because whenever you send a query to the blockchain network, if you want to get the data, then that is fine. If you want to make a transaction, then obviously it has to be connected with crypto wallets and all. But when you look at centralized apps doesn't need any crypto wallet. Only your applications are, sometimes some applications will have in-app purchases. When you have in-app purchases, then obviously it should be connected with some wallets like PhonePe or Google Pay or Amazon Pay, something like that, that will be connected with your account on the mobile apps, right? So but when you look at decentralized apps, so there will be no bank and there will be no third party here. So you have to purchase some ethers, or you have to purchase some cryptocurrency based on the blockchain you use, and based on the blockchain available, which is connected to your blockchain, it is where your decentralized app will be connected to the blockchain network. Every blockchain will have its own cryptocurrencies, and based on those cryptocurrencies, the transactions will happen on the back end, okay, on the DApp. So simply as a beginner, if you want to understand, front end is same as HTML in both centralized app and decentralized app, and the back end will change. And on centralized apps, you will be using a normal database server like MongoDB or MySQL, so in order to store your data. But in the blockchain, in the decentralized apps, you will be storing the data in terms of blocks, and that blocks will be connected in the blockchain. So in the blockchain network. So if you look at the comparison between the apps and decentralized apps, backend will change. Okay, so backend will be modified. So here the backend is nothing but a simple blockchain network. Okay, so I have taken this problem statement from Truffle suite, which is very popular, the popular decentralized application for designing a decentralized app for pet shop. So here in this pet shop, so there was a owner here, Pet is Candle. So he is the owner. He is interested to deploy his application on the decentralized blockchain server called Ethereum. So in the first webinar, I told you what is the difference between Bitcoin and Ethereum, because nowadays people are calling me and asking me which blockchain network you are using for storing all this data. We cannot store all this data in the Bitcoin, because Bitcoin is related to financial blockchain where you can make financial transactions. But if you want to store some data like this, if you want to store some non-financial transactions, then obviously we have to prefer the non-financial blockchains, which are like Ethereum. So Ethereum is a very popular public blockchain where you can store non-financial data. So here what is the concept here? The concept of this problem is able to create a decentralized app for the pet shop, where the pet shop is holding some different 16 pets. Okay, if you want to adopt a pet, you can purchase that pet and you can start taking that pet from the pet shop, okay, by a simple user interface. So he wanted to see a decentralized app which is built on Ethereum in order to give a user interface to the owner. So owner has to choose the pet from the web page, so where that web page will be connected with the blockchain network. Okay, so today I will be showing you this process of connecting your smart contract with simple user HTML pages. Okay, so I'll be using a simple example. I cannot do it from scratch because I cannot write from scratch, because if I start writing from scratch, it will take another 2-3 hours. So that is why I'm taking a user example, which is already you have a box in Truffle suite. So when you have a box, then obviously no need to write from scratch. Only some parts we have to add and modify to the box so that we can easily implement it. Okay, so the main concept here is we have to create a decentralized app for the pet shop. So you will have different types of dogs. You will have different types of 16 dogs here available in the pet shop. So he wanted to create a user interface, and from the user interface he wanted to connect that user interface with the blockchain server. So as of now, the blockchain server is Ganache. So as it is running on the back end of my system, I'll be using that Ganache, and that Ganache is connected with my crypto wallet, right? Metamask crypto wallet, it is already connected in the step 1. So I'll be using that Metamask, and I'll be using this Ganache server, blockchain server, in order to deploy this application. Okay, let me jump into the step 1. So requirements. So before we get started, what are the requirements? So if you want to create smart contracts, or if you want to create, obviously we have to create a smart contract, but before we create a smart contract, we need some requirements here. And the requirements, prerequisites are like node.js, as we talk about this from step 1, right? So we need node.js because we are installing all the commands through npm. So we are using all the development environment in JavaScript. So node.js has to be installed, node package manager has to be installed, Truffle Framework has to be installed. So we have already installed it. Ganache, so Ganache is also available. So we have downloaded and we have made running it, and we have also connected to Metamask. Light server is a built-in in npm, so we can use that server directly in order to host your web server. Okay, we have to host the web server because that will be acting as a user interface. So here I wanted to create a user interface in terms of web application. So that web application is a user in the front end, and the back end will be the blockchain network. Okay, so the step 1, we have to install Truffle. So we have already did it. in the earlier parts, right? So as we discussed about Truffle, Truffle is a popular framework which is used to create some blockchain decentralized apps. Okay, if you want to install it, you can install by using this command, and make sure that you have node.js and npm. If it is not available on your system, you can download it from nodejs.org. So that is the community website of Node.js. And step 2, now we have to create a directory. So as we did for the previous MetaCoin, so here also we have to create the same process. We have to use the same process. We have to create a directory, and then we have to enter into the directory, and then we have to unbox. So as I said, unbox is nothing but, this is a default project which is very popular project. In order to understand how to build decentralized app, let me unbox it so that we can start doing it. I'm just going back. Okay, let me create a folder, mkdir space webinar -dapp, cd space webinar -dapp, which is like I'm entering into that folder. So here I wanted to unbox it, truffle space unbox pet-shop. So here we have created a directory, and then we have entered into the directory, and then I'm just unboxing it. I'm just downloading some predefined package which is related to pet shop, the pet images and some set of files which are already there written in the truffle suite. I'm just downloading them. Okay, so let me type ls. If I type ls, you can able to see different types of files that are generated. So out of which the most important thing is contracts folder, because all the contracts should be in the contracts folder, and migrations, all the deployments should be in the migrations folder, and the test scripts, so all the test scripts should be in the test folder, and you will get one more folder called src. So in src, your HTML file, your JavaScript file should be there, okay, which is able to handle server. Okay, so here let me jump into contracts folder. So cd space contracts, let me type ls. So you can able to see only one file, which is migrations.syl. Okay, migrations.syl is only one file which is available there. Now we have to create the contract. Okay, let me jump back to the presentation and show you that. So we have understood all this, right? So contracts, it will be holding contracts folders, contracts and all. Migrations, it is used to migrate. Test, it is used to test the smart contracts. Truffle-config.js, so that is a configuration file related to Truffle. Okay, so you should not delete any files which are unboxed from the pet shop. Now we have to create a Solidity file called adoption.syl, and we have to create a smart contract with the name adoption. Okay, before we create a smart contract, let me verify the Truffle version. Okay, so here Truffle space version. So we have to understand what is the version of the Solidity compiler attached to the Truffle framework. So now it will display the versions. Okay, so the Solidity is 0.5.16 because we have to use the same compiler version, right? So let me create a file. So what is the syntax? Sudo space nano space adoption.syl. So sudo space nano space adoption.syl is nothing but creating an empty Solidity file. So it is asking my password. Let me enter my password. So an empty file is created. So here we have to start writing program. So if you are aware of Solidity, so in the first class, in the second class also, in the second webinar, in the first webinar, I have given you some syntaxes. So let me use the same syntaxes. So here let me tell the compiler which version it has to use. Say pragma space Solidity space 0.5.16, so that is a version here. Okay, comment the compiler version here. Okay, so you have to change the compiler version. Okay, if you update your Truffle, if you get another version, then you have to write that version here. So as of now, for me it is showing 0.5.16, so that is why I have written 0.5.16 here. Now we have to create a contract. If you want to create a contract, contract space adoption. So this is the contract name and flower bracket open and flower bracket close. So we have created a contract. In this contract, what we have to do is, so if whenever you adopt a pet, you will be having your address, right? For example, say if you want to make a PhonePe transaction, so what is important? Mobile number is important. If you don't have any PhonePe account related connected to your mobile number, we cannot make a transaction, right? So here also there should be some account number, there should be some mobile number in order to make some transaction. Okay, that is nothing but wallet address. Okay, that is nothing but wallet address. So what is your PhonePe wallet address? PhonePe wallet address is nothing but mobile number. What is your Amazon Pay wallet address? That is nothing but mobile number, right? So using your mobile number, you will be transferring some money. So here also you have to mention that address, okay, which is like, address. So we have to create an array, okay, because there are 16 pets here. There are 16 pets, we have to create an array. So I have explained the syntaxes in the second webinar, how to create an array and how to define the scope. So public space adopters. So adopters are nothing but public people who wants to adopt a pet. So there are 16 pets here, that is why I have taken 16 here. If you have 32 pets, then you have to mention that number of sizes here, okay, because every one owner will adopt one pet, or one owner will adopt two pets, that is up to the owner. So here adopters is nothing but a variable name, so which is like an array, okay, this is like an array of adopters who wants to adopt the pet, okay. After that, we have to create two functions here. One function to adopt the pet, and the second function is to understand who adopted them, okay. So let me write one function. You know how to create a function because we have explained in the second webinar. Okay, if you come to this webinar directly, you may get confused. Follow the order. If you want to understand this webinar, you have to understand first webinar. After understanding the first webinar, you can understand the second webinar. Once you understand the second webinar, you can easily understand third webinar, if you are a beginner. So I suggest you to go through all the webinar series, okay, because they are connected. So here let me define the function space adopt. Say this is the function name. So here we have to pass some arguments. So in the second webinar, I have discussed a lot of data types in the Solidity programming language, out of which there is one data type called unsigned int. Unsigned int is one data type, unsigned int space pet ID, which pet I wanted to adopt. And the second one, okay, I'll be passing, I'll be collecting the receiver address directly in the function. So let me use one argument here. Let me give a scope public returns. Let me return unsigned int. Okay, it is having one argument and one return variable. Okay, and flower bracket open, flower bracket close. So inside this adopt function, I have to check what is the pet ID here. How many pets are there? There are only 16 pets. So I have to check require. So this also we have discussed in the second webinar. Require, what we have to require? The pet ID should be greater than or equal to 0, double end. So there are operators also in Solidity. So that also we have discussed in the second webinar. Pet ID less than or equal to 15. So if your pet ID is greater than or equal to 0, since we have only 16 pets, here, so the ID say pet ID is 0 to 15. Okay, so 0 to 15 is nothing but 16. So we are just checking whether the pet ID is in between the range or not. If it is not in this range, you will get error. Okay, so let me store the address. Okay, so let me store the address who adopted it, which is like, adopters of pet id, adapters of pet id equal to, so in the previous webinar we have discussed about message.sender. So message.sender is nothing but the crypto wallet address, so this we have discussed in the previous webinar also. And then let me return the pet id. So here the same argument, I am returning the same return variable. If I say, if I want to adopt a pet id 2, then what will happen? So you will be calling this function adopt of 2, you will be calling this function as adopt of 2, then immediately what will happen? So that will be, the 2 number will be compared with 0 and 15. If it is in the range, then only it will continue. If it is not in the range, if you have adopt of 20, then that will not be in the range, right? If it is not in the range, it will not continue there. So adopt of 2, so the pet id is in range in between 0 to 15, then what will happen? So when I adopt it, so immediately it sends a request to my Metamask crypto wallet, and certain amount of transaction fee will be charged in order to do this transaction, right? So there, that crypto wallet address will be stored as message.sender, because sender is nothing but a crypto wallet. From crypto wallet it is sending a request to the blockchain network, thereby message.sender is nothing but the crypto wallet address, so which is nothing but our address. So that address I am storing in adapters of pet id. Then what will happen? Say if my address is say 0x20, say, but it is a 40 value, right? You will have a lot of hexadecimal values of 40 byte, but as of now 20 byte, but 20 byte it will be split into 40 byte, right? So 0x20 say, so that is nothing but address. So that address will be assigned to adapters of pet id. Then what will happen? So in the adapters array, so this 0x20 will get stored. Okay, so this is how you need to create a contract, which is nothing but adopt function is making some adoption there. So it is collecting who adopted it, so that value will be stored in adapters of pet id. And also here who adopted them, so here also we have to create one function. Let me write function keyword here, function space get adapters of public view. Okay, so we have discussed all this in the previous webinar, you can able to say that. Returns, so I wanted to return the address of 16, so address here it is 16, right, which is array space memory. Okay, since it is dynamic memory allocation, so we have to use a keyword called memory. Okay, now we have to return this array. So what is the array which we want to return? We have to return the array name. So what is array name here? Which is nothing but adapters. Since adapters is address of 16, so what is address of 16? Address is a data type like integer. So in Python if you see, you will have integer, float and string, right? So here address is nothing but data type and Solidity, so which way it will return. So here it is returning the array name. What is array name here? Adapters is array name, so that it will return, okay, when you call this function. So when you call this function, all the address of different pets will be acquired out. Okay, so this is the second function. So thereby we have completed the smart contract. Okay, control X, it will ask yes or no, press Y and hit enter. So you can go back to this. Okay, so we are done with creating smart contract. So we have created a smart contract here. So in the presentation also I have explained this. So if you here we have to create an array and we have to create a function called adopt, and we have to store that address in adapters and all. If you want to view who has acquired them, okay, you can call this function. So when you call this function, immediately you can able to get all the details of the pets who adopted them. Okay, so let us talk about how to compile the smart contract. If you want to compile the smart contract, you can use this command called truffle space compile. By using this command, you can easily check is there any mistake and all. Okay, so let me type truffle space compile. your smart contracts will be compiled. So it will be calling the respective files which are there in the contracts folder. So there are two files, right? One is adoption, which we have created. Migrations, it's already default file when you download the box. So it will be holding that file. So adoption is a file which we have written. So there is no errors. So you can easily see compiled successfully. And in the contracts, so artifacts are been copied, are written there into the build contracts folder. And by using this build contracts folder, you can able to get the application binary interface and also the contract address when it is deployed. Okay, so we have compiled the program. So after compiling program, we have to create a migration for this smart contract. So let me do that. Let me show you how to migrate this smart contract. Let me type ls. So I have created a contract and I have to migrate this contract onto the blockchain network. cd space migrations, and when you type ls, you can able to see one file in JS format, so which is like JavaScript. So one underscore initial underscore migration. So always keep a point in mind. Generally here people commit mistake. They will create with the different file names and all, but here the files which you create in the migration folder should have a number starting and the order should not miss. So here one underscore initial underscore migration.js. Now what you have to do is you have to create a file, sudo space nano space 2. You have to start with 2, okay? You should not start with 3. So you should start with 2. Then the order you should not mismatch, okay? 2 underscore deploy underscore contracts dot js. So this is the file which I am creating here in order to migrate my smart contract. So 2 underscore deploy underscore contracts dot js. So I have to create a migration of my smart contract which is created in the contracts folder. Let me hit enter. So when I hit enter, an empty file is created. So here on this empty file, we have to create a migration. Okay, let me define some variables, JavaScript variables. Variable space, some variable name. So say adoption, okay, equal to, I have to load the artifacts. Okay, by using artifacts only, I have to migrate my smart contract onto the blockchain server. So generally, if you want to get those artifacts, you have to compile the program. So we have compiled the program in the previous step. Now by using that artifacts dot require. So we have created one artifact called adoption.json. Okay, adoption.json. So this file is created when you compile the program. So which is where adoption equal to artifacts dot require of adoption.json. So previously in the previous step also I have shown you this JSON files, right? So the JSON file will be holding all the details related to the smart contract. So when you compile it, so you will get opcode, right? So that opcode will be available in this JSON format. Now here we have to deploy this. So let me show you the syntax how to deploy this. So module dot exports equal to function of deployer, flower bracket open and close. So we have to deploy this. Which we have to deploy? We have to deploy deployer dot deploy of adoption. So here this is the variable name which we have declared in the previous line, adoption. So then immediately your smart contract will be migrated onto the blockchain network. Okay, that's all. So let me exit from this, Control X, Y enter. So we have created a migration. Let us migrate, cd space dot dot. So if you want to migrate, you have to type truffle space migrate. So that is the next step. You have to migrate. Now if you want to migrate, then obviously you have to ensure that your Ganache is working, okay, because I will be using Ganache now. So what is the command here? Truffle space migrate. So let me open my Ganache and see whether so what is the first address here? 0x45, which is 3147. It is having 100 ethers as of now. So the transaction count is 0. Okay, and blocks, there is only Genesis block here. Okay, and let me migrate this. Okay, let me migrate this contract, truffle space migrate. So whenever I migrate, okay, the programs will be compiled, but already the programs are compiled, right? So the programs will be compiled and the migrations will happen. So in the migration we have connected with smart contract, so that migration will be deployed. You can able to see here. Okay, let me check, there is some error. Okay, we have JSON file, right? Adoption. There is some, maybe, let me check. nano2 underscore deploy. Module variable adoption equal to artifacts require. It is spelling is. Okay, this is a function call, so we forgot to keep semicolon. Okay, let me once again migrate. So this time let me reset. Okay, truffle space migrate hyphen reset. So as I have migrated previously, okay, I am resetting it. Now the smart contracts will be compiled. Could not find artifacts for adoption.json. So let me open this and let me see whether it is okay. So here it is showing 2 transactions are happened. Let me check in blocks. Okay, let me check what is there. The contract has been made. The contract has been deployed. Could not find artifacts for adoption.json from any sources. Something is missed. Let me check the program cd space migrations. Sudo nano2 underscore deploy contracts. Deploy underscore contract.js. So dot require of adoption, so that should be the name of the file. Okay, so yep, I have modified it. Okay, so let me migrate once again truffle space migrate hyphen reset. Okay, now again it will be compiled, so nothing to worry. So there is no problem with the thing. Okay, now it is deployed. Again there is a mistake. Deploy.deploy so it's spelling mistake. So when I type programs, so there is a spelling mistake there. Give me a second. Let me change the spelling to _deploy. Deployer dot deploy. Okay, so generally I used to type program. It's deploy. Okay, let me run the program once again. Let me migrate it. Truffle migrate -reset. Okay, now it will be deployed. So your migration will also be deployed. So there is some spelling mistakes. Okay, so nothing to worry. So I think it's up to date, nothing to complete. Okay, now it is done. Okay, your adoption smart contract is deployed. The block number is 3 and you can able to see smart contract address 0xe0. So that will be copied to the artifacts file. So this smart contract address will also be saved, and we will be using that artifact in through JavaScript in web3.js file, and so that we can make some transactions from the front end. Okay, so we have done migration also. Let me jump to the next step, and we have to test whether the smart contract is working or not. Okay, so let us jump into test folder. After migrating the smart contract, we have to check whether it is working properly or not. If sometimes sometimes some people will be skipping this step. So if you skip this step, if everything goes correct, then obviously there will be no issue. But if sometimes you need to debug yourself, right? So every step has to be debugged. So sometimes you will have spelling mistakes like this. We have to understand where is the problem and all. So that is why test comes in place. So before connect this to Metamask crypto wallet and all, so let us verify whether our functions are properly calling or not. Okay, so let us jump into text file and let us write some contract file there. So let me jump into test folder, cd space test. In test folder, let us write a smart contract called test adoption.syl, and thereby we can able to check whether our functions are correctly configured or not. Okay, so let me do that quickly. So let me clear the screen. Sudo space nano space, let me create a file called test adoption.syl. Sudo space nano space test adoption.syl. So an empty file is opened. So let us import the compiler pragma space solidity space 0.5.16. So that is the compiler version. And let us import some files, okay, some artifact file and also the deployed address file and all. So import space, so importing some modules, okay, I'm importing some modules. Import space double quotation open truffle from truffle. If you want to throw some errors, so we have a set module, and also let me import one more module which is deployed address module, deployed addresses, because our smart contract is deployed on the blockchain, so we have to use this file in order to communicate with the smart contract on the blockchain network. Import space truffle slash deployed, so addresses truffle slash deployed addresses.syl. After this, what we have to do, we have to import our contract also. Import space double quotation open slash contracts slash adoption.syl. So this is our contract. So the built-in contracts are like, the built-in files are like truffle slash, so but here it is dot slash. This is the adoption.syl which we have created in the previous step. Now we have to create a contract. Let us create a contract called test adoption. So we have to check whether your smart contract which is deployed on the on the blockchain network is working properly or not. So I'm creating a contract called test adoption. So here let me let me check the contract address. Okay, so adoption space, so this capital A, because here Solidity file is capital A, so that is why we have to write capital A here. Adoption space, a small adoption, or you can take mummy equal to also. Adoption equal to adoption of, you have to get the deployed address. Okay, so you have to get the deployed address. So deployed addresses dot adoption. So this will get the smart contract address which is deployed on the blockchain network, that will be stored in the adoption there. Okay, let me write the comment, let me share all these files through GitHub to you so that you can also test this. Let me write, smart contract address has been stored here so that we can access the contract functions. Okay, so let us have some pet ID. Okay, so let us have some sample pet ID. Okay, let us take unsigned int expected. So normally test is compared with expected result and the result which is got, right? So expected pet ID equal to 3, say expected pet ID equal to 3. This is a sample pet ID here. And also let us acquire the current address of the wallet. Okay, so this is like the owner wallet address, which means our wallet address, because right away we are checking our application, right? So address space expected adapter equal to the current address of this, which means the current address of the wallet. Current wallet address will be stored in expected adapter. Okay, so after this what we have to do, we have to call the respective functions. Okay, so we have to call the adopt function. Okay, because we have to test it. Why we have to call the adopt function? Because we have to test it. So here function space test user adopt, you can write anything here, pet. Okay, let me write public, anyone can access. Okay, so here let me have unsigned int returned ID. So the ID will be returned, right? So when you call this, adoption is a smart contract address where it will store. Here we are storing the adoption, which is like smart contract address storage. So adoption dot, so we have to call the function. So what is the function? Adopt. And here we have to pass the pet ID. The pet ID is 3, that is stored in a variable called expected pet ID. Okay, and then if there is any error, okay, how to find error? By using asset dot equal, if they are not equal. Okay, the returned ID, so returned ID is returned ID variable, comma expected pet ID. So expected pet ID, if they are equal, fine. If they are not equal, then obviously there is some error. Say I'll write error in adoption. Okay, I'll write some custom message saying that there is some problem, okay, if they are not equal. So in the similar way, let me check the second function also, which is retrieving the adapter address. So let me call the get adapter function, or let's say we have returned adapters function. Okay, so this is also we have to test it, because in the smart contract, if you see in the previous contract, we have created two functions. One is to adopt, the second one is to get the address. Okay, so let me write function space test get adapter address by pet ID. Okay, we have to pass the pet ID, then it has to return the address. Okay, so here let me make it public, the access. Let me define the function. So here what I have to do, I have to create a local variable address space adapter equal to adoption dot adapters of expected pet ID, expected pet ID. So here adapters are nothing but array of adapters. So here what we are doing here, we are adopting one pet, and when we are adopting one pet, then what will happen, our address will be stored, right? So we are checking whether the adapter is holding our address or not, which is nothing but asset dot equal of, so here let me write adapter comma expected adapter comma say, so error in acquiring address. Okay, so both the addresses will be verified. So if they are equal, so nothing will happen. If they are not equal, then immediately we will be getting the respective error. Okay, so everything is right. Let me check for one time. Spellings are very important. Let me check my spellings. Pragma, import, we have imported modules, contract test adoption equal to, so here we are getting the smart contract address, and then we have assigned some value to the expected pet ID, and then address expected adapter equal to address of this. So the current address will be assigned to expected adapter, and then we are checking in the two functions. One is adopt pet. So here we are calling the adopt function. We are passing expected pet ID. So expected pet ID is assigned to adopt function, then it will return some value. So if you remember, in the adopt function we have written the same value, so that is returned to returned ID. So returned ID and the expected pet ID are comparing here. If they are not equal, you will get error in adoption, and here we are getting the adapter address. So if they are equal, fine. If they are not equal, you will get error in acquiring address. So fine, everything is fine according to my knowledge. Let me exit from this, Control X, Y, enter, and let me test this. Okay, so we have created it. Let us test it. If you want to test, let us do a command called truffle space test. Okay, so when you use truffle space test, immediately that will be tested. Okay, so let us test this. Let me go back and do truffle space test. Then immediately the script which we wrote will test the smart contract which is deployed on the blockchain network. If there is any error, the respective asset exceptions you will get. Compiling the test adoption file, so there is no error, spelling mistake is not there. So it is now testing whether your functions are working properly or not. If they are working properly, then obviously there is no mistake here. Okay, so you can able to see there is no problem with the functions. So you got 2 green tick marks here, which means that there is no problem with the scripts. We can jump into the connecting this script smart contract with web3. So web3.js is a JavaScript API, so we have to connect. So here, before we deploy this, we have to connect the smart contract with web3.js. So web3.js is nothing but JavaScript Ethereum API, where you can connect the backend with front end. Okay, let me jump to src folder. In the src folder, you will have HTML page. In that HTML page, you will have different types of pet images. Beside each and every pet image, you will have adopt button. So when you click on adopt button, immediately it will send a request to web3.js. So the web3.js will be acting as a bridge between the smart contract and the front end, which is written in HTML. So generally in HTML, you will be having all the user interface elements like buttons or the text elements or image elements that will be written in the front end in HTML, and the back end is blockchain smart contract. So in between the smart contract and the HTML, so this Web3.js will be acting like a bridge. So this is like an API which is used to bridge the smart contract with the HTML page. So let us do that. So let us jump into src and js folder. So ls cd space src cd space, or let me type ls, so you can able to see HTML file. So this HTML file will be hosted on the server when you run the server, but before we run the server we have to configure the smart contract with this HTML file. So to do that we have to jump into JS folder, cd space js, ls, you can able to see web3.js and also Truffle contract and also bootstrap. So we are using the bootstrap in HTML in order to create some styling and all. So app.js, so let us open that app.js. So we have to write some code here, sudo space nano space app.js. Okay, so in app.js already there is some code, but we have to write our smart contract functions here. Okay, so if you look at this, your app will be initialized. Your app will be initialized when you refresh the HTML page. So app.init, so it is calling app.init. So app.init is here. So this function will be initialized. In this function, what is there? So here we are loading the pet images and we are displaying on the website. Okay, so and then we have to initialize the web3 package also. So we have to configure web3. So where is our web3? Our web3 is nothing but an API which is used to connect Metamask wallet, because through Metamask wallet we need to configure, right? So we need to configure it. So let us write some logic here. Let us write some logic. Let us write some logic here so that it will try to connect with the web API there. Okay. Okay, there was some issue with the internet. Okay, so let me jump to this init contract which is initializing the contract. So let me call the JSON file which is artifact file. So $.get JSON of adoption.json. So this is a JSON file which we have created while compiling the smart contract. Comma. So here we have to define the function of data, flower bracket open. Let me close the flower bracket and let me put bracket semicolon. So this is how the JavaScript functions are called, right? So here let me take a variable name adoption artifact equal to data, so which we have passed as an argument, and here app dot contracts dot adoption. So from the contracts there is a contract called adoption equal to, we have to pass the artifact file, because artifact file will be holding the application binary interface and also the smart contract address. So we have to call that by using the Truffle contract of, so we have to pass the artifact file here. So what is artifact file? Adoption artifact. So we have to pass this. After that we have to pass the provider, so which is like, you know, app dot contracts dot adoption dot set provider. So we have to set the web3 provider here, which is like, you know, app dot web3 provider. So when you refresh the page, so all this will be initialized for one time. So from then you can directly access all the pets. And here we have to return if there are already adopted pets available, then we have to return that. Okay, so app mark adopted. Okay, so here what we did, we have created a function. So we have read the data from the adoption.json, because adoption.json will be holding all the details related to the smart contract, and that we are passing to here data. So that will be stored in adoption artifact variable here, and that adoption artifact variable we have called through Truffle contract. So here what will happen? It will get the necessary the contract artifact file, and also it will instantiate. Okay, so which means it will initialize for only one time when you refresh the page. So that's all about the initialize contract. So we are done with this, and then we have to go for the mark adopted function. So because it is calling from here, so initially we have created a Web3 API, we have understood what is the Web3 API there, and then we have created, and then we have initialized the contract, and then now we have a function called mark adopted. So we have to jump to mark adopted function. So let me yes, it is here, mark adopted function. So here let me define a logic in order to understand which pets are adopted already. Okay, so let me create an instance. So where adoption instance, so we have to create an instance, and here we have to check. Okay, we have to create a function. So app dot contracts, we have to call the function. Okay, so app dot contracts dot adoption deployed. So this is a deployed, which means the contract is deployed. So we are accessing it, the smart contract, which is like if then. Okay, then function of instance. So we have to pass the argument called instance. Flower bracket open. So let me close the flower bracket, close the function, semicolon. So here inside this, what we have to do, we have to load that instance into the adoption instance variable first. So adoption instance equal to instance variable, which is nothing but instance will be copied to adoption instance, and it will return. So it will return adoption instance dot get adopters. So this is a function which is created in the smart contract dot call. Okay, dot call, and then flower bracket close, parenthesis close, dot then we have to read all the data from the adopters, right? So a function adopters, flower bracket open, flower bracket close, and bracket open. So here we have to read, okay, by using for loop. For I equal to 0, I less than adopters dot length, which is 16, and I plus plus, flower bracket open. So inside this for loop we have to identify, okay, if adopters of I is not equal to, this is not double equal to, okay, so say we have to write 40 zeros, because the address size is 20 bytes, right? So we have to write 40 bytes. So for 20 bytes, which is nothing but 40 zeros, because 2 zeros has 1 byte. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, and 20. Okay, so which is like, the dummy address. So generally you don't have this address, right? So I'm just comparing. If it is not equal to, then obviously you will have the original address there. Okay. If adapters of I is not equal to this address, then obviously we will be having some address, right? So flower bracket open and flower bracket close. Okay, so here we have to disable the button. Okay, so if it is already adopted, we have to disable it. So $of dot panel of pet. So for this pet we have to disable, okay. So we have to create a constructor here. So by using eq function object dot find of, so we have to find where is that button available, okay, where is that button available, and also where is the text available, what is the text it has to display. So instead of button it has to display success, so which means that it's already adopted, okay. So dot attribute, so we have to disable the button, so disabled comma true, so the button is disabled there. So we have to close the if loop and we have to close the for loop, and we have to write dot catch, say if there is any mistake, okay. So then catch, we have to store the error log, right. So function of error console dot log of error dot message. If there is any error, so in doing this logic, okay, so I'm just wanted to log it in the console so that we can able to understand where is the error, okay. So this bracket, I guess it is for the, so anyways we'll check that later when we run the program, okay. If there is any error in the flower brackets and all, we can check it that later. Now let's write this final logic, so which is handle adopt. So here we have to make a transaction. If I want to adopt a pet, then I will be clicking this function, okay. So when you click the button, so that will be calling this handle adopt function. So in the handle adopt function we have to write some logic in such a adoption instance, and we have to create a variable, and then web3 dot eth dot get accounts. So from that accounts we have to pass error comma accounts, okay. We have to access the crypto wallet here. Dot bracket, if it is error, log the error. If it is error, let us log the error, console dot log of error, okay. If there is no error, then fine. So let us have variable account equal to, so let us take the 0th account from the Ganache, okay, accounts of 0, and let me write app dot contracts dot adoption dot deployed. So I'm just calling the smart contract here. Then function of instance, so through instance object I'm just calling the smart contract. So here adoption instance is the variable which I have created, that I'll assign with instance. So the instance will be stored into adoption instance. By using this adoption instance, I will be making the function call. So now we have to make the transaction. So here let me use return space adoption instance dot adopt. So this is the function call which we have to make. We have to pass the pet ID, comma, from which account, which the money has to be deducted, the transaction fee has to be deducted. Okay. And then we have to execute it, right? So we have to execute the result. So dot okay, this has to be closed, this has to be closed. So let me write in the second line, dollar then we have to return the result, function of result, return app dot, So we have to pass to mark adopted so that it will be adopted, it will be marked as success. And also let's write error, okay. So if there is any error, okay, function of error, let us log it, console.log of error.message, and then we have to close this functions, okay. So one is closed, so I guess you need one more, okay. So this is the transaction that we want to make, which is like dot adopt. I'll share this program, don't worry about the program. I'll share this program to your emails so that you can also check it out. So this is how you need to make you need to interact, you need to create a bridge between the smart contract and the HTML page by using the web3.api. So anyways, in the next week I will be making a tutorial on web3 particularly. Because here we will be using web3 API in order to call the smart contract functions and all, okay. So let me jump back, so let me exit, Control X, Y, enter. If there is any mistake in the syntax, okay, anyways let us debug it, okay. So no need to issue there, no need to worry about it, right. Okay, so let me jump back to the so that's all. So we have to go for the last part, which is deploy and test. So by using light server we have to deploy it. So let us check what is there in the bs-config, and also let us check what is there in package.json, and by using this command called npm space run space dev we can deploy the server, okay. So let me check what is there. So let me say cd space dot dot, let me come out of the folder. Let me check what is there, sudo space nano space bs-config.json. Okay, let me enter my password. So our bracket open, server base directory. So in source folder we are having HTML page. In build/contracts we are having the artifact, so that they're related to the smart contract. So everything is there. So let me open package.json also. So this is the package which is related to Truffle, okay. So we have light server here, and truffle.javascript file is also included. If there is any error, so that will be logged in the console of JavaScript, okay. So let me run the program, let me run the server. So if you want to run the server, so npm space run space dev, so immediately the server will be on, the light server will be on. So immediately it will be redirected to the HTML page. So your pet animals are not been displaying, your dog pics are not been displaying here, so there is some mistake in the program. So let me open the console, inspect. So immediately console will open. So in the console there are two errors, it is showing there. So 70th line, in 70th line there is some mistake. Let me jump into the 70th line, okay. Let me open the, where is this, home. So we have created webinar DAP Dapp. So here in the src in JS, as we are typing there are some mistakes in the program, okay. Let me open with text editor so that we can able to identify the line numbers, okay. So as per the console, what is this console? In the console it is showing in 70th line there is a mistake. So let me open this and see in 70th line, yes, single quotation is missed, so that is a mistake, okay. Let me, yes, now you can able to see the pet images, right. So that was a mistake. So you can able to see in the console, okay. So if there is any mistake you can able to see here, and you can check whether the web3 API is working or not by using a command called web3 here. So when you type web3, immediately it has to respond. So here you can able to see the written result of it, right. So it means that your browser is supporting web3, okay. Why it is supporting web3? Because we have Metamask wallet here, so that is why it is supporting web3 object, okay. So our account is 4, okay. So let us adopt one pet animal here. So as of now you can able to see every pet is enabled with adopt button, okay. every pet is enabled with adopt button. So we have to click on, say if you want to adopt this pet animal, okay, you need to click on adopt button. When you click on adopt button, it will send a request to Metamask wallet, okay. So the Metamask wallet is connected with Ganache server. So Ganache, it is running on blockchain server, right? So it is sending a request to Metamask. So we have to make a transaction. Okay, let me click on confirm. When you click on confirm here, gas fee and data. If you look at data, so there is some data which has been transferring there, which is in the format of the exa data over here. So this is nothing but pet ID. So if for example say, this is 1, this is 2, this is 3, this is 4. I have clicked on this adopt button, so 4 will be transferred. When I click on confirm, immediately you can able to see the success. So the button is disabled because in the program we have written a logic in such a way that that button has to be disabled, right? So where is that? Here it is. So the button has to be disabled. So thereby you can able to see success when you adopt, okay? When the transaction is made, then immediately that button is disabled here. Say for example, if you want to adopt this particular pet, okay, you have to click on the adopt button. If you look at this, it looks like a normal application, okay? As I said, because front end will never change. In the centralized app or the decentralized app, it looks like a normal web page. But on the back end, it will be connected with crypto wallet. So when you click on adopt, the Web3 API will be sending a request. Web3.js API is sending a request to crypto wallet. In the crypto wallet, it is connected with Ganache. So it will send a request to the contract which has been deployed on the network, and the data is getting stored. So you can able to see success here. And in the similar way, when you look back, when you jump back to the Ganache there, if you see there are blocks being added into the network, okay. So if you select one particular block, you can able to see the firm address and the transaction hash and all. You can able to see the contract address and all the sender address, which is like sender address is nothing but 3147. So that is a sender address. So here Metamask is also on address called 3147. So previously also I have shown you that. Which is 3147, okay. So you can able to see here adopt, which means that we have adopted one pet. So if you want to adopt this pet, again you have to click on the button. So the process is same. It will send a request to the Metamask API. Since we have called this, right, so we have initiated a contract, we have initiated a Web3 API in such a way that, so the current provider, what is the current provider here? The current provider is nothing but Metamask. So in the console, when I type Web3, you will be getting some response, right? So sometimes, if the Metamask is not available in your browser as an extension, you'll get error. When you get error, then immediately it goes to the HTTP provider. But as of now, we have Web3 integrated with browser through Metamask. So that is why it is showing this. So it is taking the current Metamask provider. And whenever you make a transaction, when you click on confirm, so the transaction fee will be deducted, and the pet in the blockchain, the data will be stored. So all the data will be stored in an encrypted format. Okay, you cannot able to understand what it is the data there. Okay, if you want to read the data, you have to make a smart contract function. Okay, so through smart contract functions, you can able to communicate with the blockchain network based on the request. So here you can able to see the buttons are disabled and the pets are adopted. On which address they are adopted? On the Metamask wallet address. So on which address? Which is like the address of the wallet. So on this address of wallet, all these pets are adopted, and certain amount of transaction is being deducted from the wallet. Okay. So whenever you make any purchase, so whenever you click on adopt, which means a purchase, so when you click on the button, so it will send a request to Metamask, and Metamask will be sending a request to Ganache. So as it is connected there, and the transaction will be stored in the block, and it will be mined automatically, because here you'll have auto mining. So you'll have auto mining here. So you can able to see auto mining is available on Ganache server. So the block will be mined automatically, and that is why the transactions are very fast. Okay, so this is how you need to design a simple decentralized app. Okay, the only one thing, the complicated thing will be the Web3 API. So anyways, I'll make a tutorial on Web3 API in particular in the next week. But as of now, we have to use the Web3 API in order to connect your HTML page with the Metamask provider there. Okay, so when it is connected with crypto wallet, obviously you can make transactions, right? So you can make transactions directly when it is connected with Metamask wallet, because Metamask is nothing but crypto wallet here, which is connected to the Ganache. So in the similar way, when instead of connecting it to Ganache, if it is connected to the main Ethereum network, then obviously there comes the concept of the main ethers and all, right? So the application will never be changed. Okay, the only change is ethers. So ethers and the blockchain network. So here ethers are test ethers, and the blockchain network is the personal blockchain Ganache. So by using this, we are creating a local intra blockchain. So all these blocks are added in the blockchain of the Ganache, and our transactions are being made through the test ethers. So that's all. That's all about the deployment of Dapp, which is decentralized app for pet shop. So like this, you can make some decentralized applications. Okay, when you're doing it for the first time, it will be a bit complicated, but when you understand the logic and the behavior of the function calls, then obviously it will be very simple, isn't it? So thanks for joining me today. If you have any queries in relation, I will share this program and the entire project file so that you can also test on your systems. So thanks for joining me on this webinar. We'll meet you in the next webinar. See you soon. Thank you and bye.